Hi, everyone. Aaron Smith and Nancy Bakeman. We are excited to welcome you to the EBA webinar podcast series. Today, we have John Loescher, who is a certified passive house consultant out of upstate New York. And John is going to be reviewing the prescriptive path in Phius. As many of you know, the EBA Pathway to Zero, we recommend, get a HERS rating, Energy Star, Indoor Air Plus, Zero Energy Ready Home, and the graduate level course is, can you go to a Phius type of certification at the end? So we're really excited to have John talk about this. We will be taking questions throughout. We've been doing this for 2 years. The Q&A section is at the bottom of the screen. I will be curating those questions, presenting to John. We'll have a little bit of time at the end for questions. Quite a few people on here, so if we can't get to your question, we apologize, but we will certainly try to get all of them answered. With that, John, welcome.
Awesome. Thank you, Aaron. Yeah, thanks for the warm introduction. It's great to be with everyone here. Really excited about the crowd and excited to talk about the prescriptive path a bit more. Before you guys joined, I was asking Nancy and Aaron a little bit about the crowd and the spread, and based on their response here, I think this is going to be a really relevant topic. Because I really do feel that there's a lot of hope for the prescriptive path as far as making Phius certification a lot more accessible. One, on a kind of shorter timeline, but also to a lot more of our professionals. So the presentation is called Prescription for Better Buildings Faster. And we'll take a look at the Phius 2021 CORE Prescriptive Path from start to plaque. So we'll go through everything about what you need to know about the program, and then ultimately ending up how do you actually certify through this program. Okay, so the overview here is we're going to look at the protocol design first, as it's called the Phius 2021 CORE Prescriptive Path. That's the long name. We can just call it the prescriptive path. It was just released in 2021. So we've been using it for about 1 year so far, and it's still kind of new. Actually, there's still not one project certified through it, although I'm gunning for the title of the first prescriptive path certification. I just submitted my first project for the second round of review, and fingers crossed, hopefully I'll get that back in a week or two. We'll then look at criteria development. So obviously kind of related, but more specifically, what are the individual criteria that we have to hit along the way? Once we go through those criteria, we'll look at getting started. So where do you even start the process? What are the tools you need to get going? We'll look at some of the principles involved and through the lens of case studies. So although I am on the certification team at Phius, I also have operated as a CPHC for a number of years now, and essentially before my official time starting at Phius, I had worked on about 7 prescriptive path projects that I kind of wrapped into this presentation. So rather than just talking about a generic checklist, we're going to talk about it using some of these case study projects, so we have concrete examples to look at. And then finally, just some resources to know about at the very end, and then we'll take our Q&A. So ultimately, we need to kind of look at the prescriptive path in the overall context of Phius. Phius started as an official certification organization in 2012, where the climate-specific certification standard was developed. So we have about a decade of certifying projects under our belt, and that's specifically for this single-family detached typology, right? So 1,200 square feet, 2,500 square feet, like kind of that scale of single-family detached homes. We can do that really well, right? And we've certified projects like that and got good feedback from all of those projects across the country. So what we're seeing here is a bunch of different climates, all certified passive houses under the Phius protocol. And when we go through this process, great, yeah, we got a plaque on a building, but we also learn a lot about How do our targets work for our buildings? How easy or difficult is it for professionals in different areas of the country to actually achieve our standards, right? So after these 10 years of going through this process, we basically said, you know, it's time we scale this up a little bit. And of course, we're still going to offer our performance path like we always have done with energy modeling, all of that. And that's really applicable for large projects, non-residential projects, et cetera. But for this typology, the single family residential that we've been doing for a while, why not scale that up by kind of opening it up and making the process a little bit simpler for all of our design professionals? So we really need the amount of Phius professionals that we have to be, you know, doing a lot of projects, and we want to remove some of the roadblocks in the way. So first, for the existing CPHCs, the intent of the prescriptive path is to reduce the pre-certification timeline and effort. I kind of built a career around WUFI energy modeling, and I can understand that it takes a lot of time and investment into actually learning that program. A lot of, you know, pulling your hair out and, you know, time spent undoing things and starting backup models and all of that. Or you can also spend a lot of money on a energy modeler to do the work for you, right? So either way, there's a lot of resources invested into the performance path, right, where we actually simulate the performance of our building. And there's also a lot of back and forth with Phius, right? So sometimes I'd see at best maybe 2 rounds of back and forth or 2 rounds of review. We could see up to 5 rounds of review where the design team submits work to Phius, they come back with questions, and we go back and forth like that, right? So we're trying to really compress this timeline. The other part of this is that we have a lot of Phius builders now. We have a lot of Phius builders. We run like multiple trainings every year, and we get builders from across the country, which is really great. But those builders are not required on certified passive houses, and they have no ability to certify a building on their own, right? So they can't actually submit a project for design certification, nor can the rater or verifier, right? So the prescriptive path, again, the checklist-based path for certification opens up pre-design or that design certification for builders and raters, because you don't have to do that energy modeling process anymore, right? So again, we're trying to kind of call everyone to start certifying.
John, just a quick question that came up. You know, we have a lot of energy raters in the group, and are there quarterly trainings or online training if you're a current energy rater and you want to move to a Phius rater? Is that a pretty process?
So if you are a HERS rater, so that is a prerequisite for becoming a Phius rater, we can essentially check out at phius.org, and we run about quarterly trainings for the Phius rater. Now, raters are for buildings 1 story to 5 stories. And then the verifier is essentially an additional on top of the rater, which is for 5 stories and above.
Perfect.
So we'll talk a little bit about that in a couple slides too. So this is just summary, really. But again, we're trying to make accessibility for more CPHCs. So when we're outsourcing energy models and et cetera, right? Again, there's a lot of investment in time and money into the performance path. But as we've seen through certification like LEED and other checklist-based certification processes, pretty much anyone can do that, right? So we're trying to essentially move away from that performance certification to a checklist-based certification. We're removing that investment in energy modeling and allows all Phius professionals to submit for the pre-certification. So we're trying to open it up for more professionals to certify, but we also have to kind of pump the brakes a little bit. So again, we know that we can do the single family typology really well. right? So we're focusing, at least for this first round of the prescriptive path, we're focusing on that typology, right? So the whole prescriptive path is supported by the single family homes. And it's also very cost effective for large scale community development, right? So when we have that kind of cookie cutter model, right, where we have a model home and we're replicating that multiple times, but still in a detached way, the idea is that we can apply something like the prescriptive path there as well. Instead of providing 50 WUFI models, right, we can essentially provide a prescriptive checklist for the model home and essentially prove that that meets all of the requirements and then can be replicated from there, right? So you can imagine the process of certification, again, very expedited. Okay. So again, from experience, just talking about that expedited timeline, I kind of roughly mapped out a performance project to a prescriptive project. So, and this are kind of two sample projects that I had worked on my own. I don't really have a time scale here, so you're going to have to use your kind of imagination a bit. But essentially, if we look at the top part, this would be for our performance path project, right? So we can see typically there is a kind of phase in the very beginning where we have a design, but we don't even know if it can qualify for Phius certification, right? So you kind of come up with something, but it's not until you provide the energy model in the feasibility study that you're actually able to verify if you're going to meet all the requirements or not. So we have a whole period here that's essentially eliminated with the prescriptive path, right? So you can see we take this design development or concept design, and we just start there with the prescriptive path, right? Because now we have a checklist. You either hit these things or you don't. So you have to design every element of the prescriptive checklist into your project, right? So that's one time reduction here. Typically, when we kind of move on from that, we have to kind of go back and forth and adjust things with the architect, right? Assuming architect energy model kind of relationship. Now that's also greatly reduced because again, we have the checklists. From here, we would submit to Phius, right? So we have essentially right here, pre-cert review, right? So after we get all the documentation together for our project, that would be drawings, data sheets, specifications for the performance path and the energy model for the prescriptive path, a checklist. We submit that all to Phius. Again, I am anticipating as a CPHC that I'm going to get design certification within just 2 rounds of review. That's really great. For many of my projects, I'm up to 4 rounds of review, 5 rounds of review, at best 3 rounds of review. With every round of review, you get about 6 to 8 weeks, right? So every single time you want to submit to Phius, you have to wait 6 to 8 weeks. It gets a little shorter as you go, but as you can imagine, this really starts to spread the overall timeline. Okay. All right, so now a little bit more about the specifics of the prescriptive path. Again, this was just developed and released with Phius 2021 protocol. So it's been around and in play for about a year now. And the big update here with 2021 was that we essentially split our certification where we can either pursue Phius CORE certification or Phius Zero certification. And really the difference between those is just our primary energy. So the amount of energy consumption in our building, right? Phius CORE, which includes the prescriptive path, just basically preferences all of the passive conservation methods of passive building but it does not require renewable energy, right? The only difference is that Phius 0 requires renewable energy to prove you're at net zero, right? So as you can imagine, without an energy model, we are limited to only Phius CORE certification for the prescriptive path. So that is just one thing to note. It's not to say you can't put renewable energy on your prescriptive path project. It's just you cannot account for it and say that you have a Phius 0 or a net zero building, because we have no way to verify it without energy modeling, right? We are looking into in the future essentially monitoring, right, achieving prescriptive certification, then after a year or so showing that you produce enough energy on site to offset that. Was there a question there?
No, I was just sorry. I had my mute off and I was making comments. Oh, okay, that's great. So you could do a year of certification, and if your solar meter spins backwards, your net meter, you could technically.
We're pursuing that as an additional kind of badge add-on certification for the future, for sure. That has been one item that a lot of people have said, hey, I like the prescriptive path, but I am really interested in net zero. How can I bring them together? So we're listening.
Okay, good.
Okay. So just to again look at the two paths in comparison, we've already talked a lot about timeline. We're past that now. About the requirements for each. We have the performance path on the left, prescriptive path on the right. So what we're really eliminating is anything that's involved with energy modeling, right? So we have the net source energy target at the bottom. We can't model that, right? We can't model how much energy your building will consume. So that's being eliminated here. And the space conditioning target at the same level, we can't model that unless we plug in our building in an energy model with the climate data set. So rather what we're doing for our space conditioning targets is just a climate specific, right? So instead of having to go through this whole energy modeling process, you can simply plug your project size and location into a calculator, and it will spit out what your required R values are for your wall, for your roof, for your building slab, as well as a few other things. Again, so these two things are based on what we need to eliminate in order to get energy modeling out of the equation. So the types allowed within this, as well as the single family detached, we are making an exception for side-by-side duplexes as well. So we can see this still is kind of falling within that same kind of single family detached typology, while starting to move towards some notion of multifamily, right? So this is a rendering from Bartlett Swedlick Architects, a Habitat for Humanity project here in Columbia County, New York. And we can see two single family residential projects with a shared party wall, right? So we see a lot of economy in building like this. And essentially the ratio of interior floor area to exterior envelope is still similar enough to that single family detached typology that it falls within the kind of same building science principles. Okay. So some other criteria that are included within the prescriptive path, we have a limit on the size of the building or the compactness of the building. So within this, we're really talking about complexity, right? Do we have a lot of bumps, ins and outs on the building? Is it a very compact envelope, like very square and kind of, efficient? Or is it really long and drawn out, right? With a lot of surface area of exterior. Essentially, again, that calculator, the snapshot that we will put in the building size, and it will give us a limit to how much exterior envelope we can have, right? So by doing this, we're controlling the size of the building that we can actually certify through the prescriptive path, right? it kind of works against what we would call like the McMansion, right? The very large, lacking density kind of building typology, and favoring dense, energy efficient buildings from a passive kind of compactness perspective. Working hand in hand with that, we have a limit on the occupant density. So we have about 900 square feet per occupant. Essentially what that means is that, again, we're trying to limit the amount of like McMansions, which large kind of open spaces with very low occupant density. Some of the other limitations would be no fossil fuel combustion equipment in these projects. At this point, we've seen enough advances in heating and cooling equipment, specifically with domestic hot water, that there's really no problem with completely decarbonizing our mechanical systems in the building. Similarly, no jetted tubs or indoor pools are allowed because these create extra vapor problems within the building, right? When we see vapor problems, we want to simulate those with energy modeling, right? So in order to get the energy modeling out of the equation, we need to say no jetted tubs or indoor pools. Similarly, no natural draft fireplaces. We saw this with certification to begin with. We do allow sealed wood stoves. That's with a dedicated intake air and a dedicated exhaust. Okay, and the airtightness, just like the performance certification, is still critical here. In fact, a bit more critical in the prescriptive path. So if you notice the airtightness limit, 0.04 CFM per square foot, that is a bit more strict than what we typically allow for the performance path. So,
and John, just a question here, because our audience is so used to the 50 pascals, right? Can you convert that to, is it, I always heard that equates to what at 50, ACH 50?
0.3.
So 0.3 ACH.
I'm sorry, 0.6 ACH.
That's right. Yeah. So before you panic, everybody, that's what we hear is that conversion is about a 0.6 ACH 50.
So 0.06 CFM square feet roughly equates over to 0.6 ACH 50.
Got it.
Right. So we are still talking with 0.04. We're still talking a bit tighter than that.
Right. Sure.
Right. So, but not unreasonably tight. Actually, most projects that I see, single family residential again, have no problem hitting this airtightness or better.
Yeah. And you're doing that preliminary blower door before sheetrock generally, John?
See, that is actually going to be kind of case by case, depending on the project and the phasing. Right?
Makes sense. Yeah.
So the rater will work with the builder to determine what is the construction sequencing and when does the preliminary blower door test make the most amount of sense.
Great, thank you.
So one important thing about this, performance path only requires a final blower door test. The prescriptive path requires a preliminary and a final. So the conservative airtightness and this preliminary blower door test are working to ensure durability, essentially, right? So they're built into the program to make sure we're catching quality control issues as soon as possible in the process. Okay. And within this, we're also looking for, again, relative to durability, moisture risk compliance, right? So whenever we're installing windows, we want to make sure that they're going to be free of condensation risk. We are also concerned with the condensation or the dew point temperature in our wall assemblies, right? So from experience, we know when we add insulation and airtightness, we can actually invite the dew point temperature right into the center of our wall assembly. So the prescriptive path allows us to enter our wall assemblies into the checklist, and it will actually verify if we're in compliance with the Phius moisture control guidelines. Okay. As with all Phius certification, we also include the high performance staircase. So Aaron had mentioned this earlier, essentially going from building code, building on that, Energy Star, zero energy ready homes, Indoor Air Plus, Water Sense, etc., and then building on that, going to Phius CORE certification. So this is what is being verified by the Phius Rater when they show up on site. Okay. So now that we've kind of gone over this overview, we've discussed some of the limitations and some of the intentions of the path. We'll go into getting started. Like, I have a project and I just want to get going on it. What do I have to do first? So first thing that we can look at, most helpful, like I said, at phius.org, there is the prescriptive snapshot. So this is the early on calculator. Essentially what we can do is type in our location, right? So we have our state and then the city. This aligns with a number of pre-approved Phius climate data sets that we've used throughout the years. It tells us our ASHRAE climate zone, which will tell us essentially later on about our moisture control guidelines, and then the size of the project.
John, can you define iCFA for us again, please?
Yes, interior conditioned floor area.
Got it, thank you.
So essentially, it's just the interior surface of the exterior walls within the building, right? It's all of the conditioned kind of volume. So we have a size of the building governed by the iCFA, the interior conditioned floor area, number of bedrooms, number of stories. Once all of this is filled out, it populates all of our information down here. So this is a high-level overview before we actually get into the checklist that gives us all of those design requirements, right? So we can first see the general tab and the compactness tab. Those are giving us some of those high-level kind of limits, right? So we have the calculated density, 375 square feet per person in this particular building. And that's based on the iCFA and the number of bedrooms. And yes, okay, that meets the limit of 900 square feet per person, right? So we kind of progress down the checklist just like this.
And John, can you just reiterate for the audience, we have a question about how do you come to the limiting 900 square foot iCFA number? And I think you said it earlier, but can you reiterate that?
So the 900 square feet is a limit that is set by Phius. So every building within the prescriptive checklist has to be within 900 square feet of occupant density.
Yeah, and it's the anti-McMansion formulation is how you described it, right?
Exactly. We're trying to, and it's not just whatever. If you want to build a McMansion, go for it. I want everyone to be happy. But what we're trying to limit is, from an energy perspective, buildings that have a lot of building envelope and very, very little internal heat gain.
Right.
Compactness is similar, right? So we have a total maximum area of the building envelope. So for 1,500 square feet in this particular climate, the maximum compactness would be 4,989 square feet, right? So we're starting to talk about a ratio of floor area, which is indicative of internal heat gain, versus our building envelope area, which is indicative of heat loss, right? So it's essentially setting up this ratio between internal heat gain and heat loss to the exterior of the building.
Mm-hmm.
And we do have some case studies in a little while. We'll calculate that and go over exactly how that's calculated. The snapshot also gives us specific values that need to be achieved for our windows. So solar heat gain coefficient, right, 0.25.
And John, that's by climate zone that you put in for your project.
Exactly. So when you change that climate zone, it's going to change this value. For instance, we'll see later that actually some of these don't even apply depending on what climate zone you're in, right? So if you're in climate zone 7, we're not going to require you to put fixed overhangs on all your windows.
Right? We want all the heat. We want all the heat we can get up here, right?
Right. Exactly. Similarly, we'll go into our R values down here for our different assemblies, and some mechanical ventilation requirements as well for all those mechanical engineers out there. So again, the prescriptive snapshot is like that first step that we can take just to get, okay, based on my climate and my size of building, what are all the checks that I need to be aware of?
Right. And just a quick question from somebody, John. They said they're loving the program, I think, and they said, if I had scrupulous construction oversight that was documented, can I do Phius certification after occupancy?
So the only, theoretically, yes. The catch up, the kind of hold up there is going to be you need documentation of certain things along the construction process, right? So you could, if you had good documentation of sub-slab insulation, then theoretically you could work with the rater to kind of post-occupancy certify your building, but you do need to verify a bunch of things that are probably hidden at this point.
Great. So probably the advice for Dan there is reach out to your Phius rater and have a conversation with them as a first step.
Right.
Great.
Sure.
Thank you, John.
Yeah, of course. Okay. So just kind of process overview. We just talked about that snapshot. So where do we go next? Right. So from that snapshot, we can move directly into our design. We're taking all of the requirements shown in that snapshot, and we're making sure the building is designed with those qualities. Right. From the design, now we're ready to download the full checklist, right, with each of the individual, detailed points. And based on our design work, we're going to fill out that checklist. We gather those two things, the drawings and the checklist, along with any data sheets, and we submit them to Phius for pre-certification, right? So once we get the thumbs up from Phius, after maybe 2-3 rounds of review, we can go on and build it, and then have the Phius rater involved, verify everything is built the way that it was designed, and then we get the real final plaque, to install on the building. So it's kind of the oversight. Again, really similar to the performance path. Only thing difference is essentially you're swapping out that checklist for the WUFI energy model. So the documentation, like I said, the checklist, drawings, and the data sheets. Data sheets are going to be just like the performance path, or just like any other certification, right? You're literally finding the corresponding data sheet, highlighting the necessary information, submitting that exactly as it is. The construction drawings become very important, but more so than that become the takeoff drawings. Right. So for instance, in the snapshot, we're going to enter the iCFA, the interior conditioned floor area of our building. Now we want to show exactly how we came up with that value in our takeoff drawings. Right. So actually what you can see here, we see the architect's construction documents with my kind of notes overlaid on top. Right. So this is one particular takeoff looking at window to wall ratio. Basically the area of each of the windows, right? But we might do the same thing for our floor area, for our envelope area, right? Each of the individual kind of specific pieces of information in the checklist, we want to show where we're getting those values from, in the takeoff drawings. And then we can go into the checklist. So the checklist is essentially organized into 9 sections. We have project information, general information, airtightness, compactness, solar protection, thermal protection, and there's a few others that aren't on the page. And I don't have it memorized yet, I apologize. But this is a smart spreadsheet, right? So when we fill out some of the general information at the top, it's starting to kind of move ahead down the spreadsheet and fill out other information for us, right? So again, if we go back to the core of Phius certification, that climate specific quality is still really important here, right? And that's going to, as we're setting that in the checklist, it's going to factor into all the other decisions we make as we go through the process. Okay. So going through each of these 9 sections of the checklist, again, looking at some of my case studies, we can see, yes, I'm mostly in the Northeast here, but there is one case study in Virginia, so at least we have climate zone 4. So we get a bunch of case studies ranging from climate zone 4 to climate zone 6. And we can also see a bunch of varying complexities, right? So we can see a bunch more kind of very efficient compact volumes, some dormers, some less compact volumes, right? As you can imagine, through the different climates, we're also going to see solar conditions changing, insolation conditions changing, right? So each of these ends up being an own exercise in itself. So to give you the kind of high level overview before we get into the specifics of each, we have 4 of these projects are pursuing Phius certification out of the 7. The first 3 are at the top. They're all by the same designer, design build, North River in upstate New York near me. And all of them should be certified. In fact, the GC residence will probably be the first prescriptive path project to be certified with Phius. The project at the bottom in Blacksburg, Virginia, ended up being certified, but not through the prescriptive path. And the reason why was because they really wanted that source 0 certification. So again, reminder, if you're looking for the certified source 0, we can't do that with the prescriptive path at this time. The remaining 3 projects, Wellfleet, Riley Residence, and Pleasant Hill, did not meet the prescriptive requirements. 2, because of compactness issues, right? So again, we're looking at the total, sorry, I'm seeing the banana belt comment in the chat. We have, so when we're dealing with compactness, we're talking about that maximum amount of thermal envelope. And for the Riley residence, we have a very specific example within the thermal enclosure. So we're going to go into those specifics in a few slides. Okay, so we spoke about the airtightness requirement. I'm going to skip this slide. When we go into compactness, again, we're looking at a ratio of the interior to exterior, right? And it's based on this notional compact building. So essentially it says every iCFA per level is evenly distributed. So if you have 1,000 square feet floor 1, there's 1,000 square feet floor 2. 12 feet per story, so that's governing the height of the building. And we have a window to door aspect ratio of about 3. So again, this is the notional compact building that we're basing our certification on, right? So we can see as we increase the height of the floor, this diagram on the bottom, we're increasing the envelope area, but not increasing the floor area, the usable floor area, right? So if we look at some of these case studies, we can see the one project, Aunt Sally Way, that did not meet this compactness criteria. it was done for two reasons, essentially. We have a total floor area, which we can see on the bottom right here, of 1,500 square feet, right? So it's actually a pretty compact, it's not a massive building. But when we do a takeoff of the total envelope area of the building, we exceed the limit, and we end up with 6,340 square feet. Now, there's two things going on here. The first thing going on is we have a lot of inside corners, right? So we have a couple in the back, we have one in the front here. And we also have lofted ceilings, right? So essentially we're keeping the floor area of the building the same, but we're increasing the envelope because we're creating that larger ceiling height and more complexity in our building envelope. So this was a project that at the beginning, I thought for sure would meet the prescriptive path because it has very good insulation levels in all of its assemblies. But because of that complexity, it did not meet the envelope requirements. Moving from the compactness requirement to the solar protection requirement, which is number 4, this is based on climate zones. So depending on what climate zone you're in, you're going to have to deal with different combinations of solar protection characteristics. Essentially, climate zones 5 through 7 will only have to deal with a net gain score. So we take the area of all of the openings, and it will calculate a net gain score for us that we need to meet or exceed. For climate zone 4, we're dealing with a maximum solar heat gain coefficient and that net gain score. For climate zone 0 through 3, we're dealing with that same max solar heat gain coefficient, and instead of the net gain score, we're dealing with a fixed overhang requirement. So in summary, climate zones 0 through 3 are hot climates, right? They're heating dominated. So we have a maximum solar heat gain coefficient and overhangs are required. So essentially there's 2 requirements that help keep solar heat out of the building. Climate zones 5 through 7 are heating dominated climates. So they prefer solar protection. They actually prefer solar heat gain coming into the building. So of course we're going to do away with the fixed overhang requirement, right? But instead we're going to make sure that our window glazing area is enough that we're essentially taking advantage of that solar heat gain in the building, right? And then climate zone 4 is right in the middle. So you get one of each. One solar heat gain kind of invitation, and then one shading element that's keeping it off the building, right? The net gain, I'm sorry, the max solar heat gain coefficient. So when we fill this out in the checklist, it's going to essentially give us these different requirements that we need to satisfy. Within our thermal enclosure, this is probably the most time-consuming portion of the prescriptive path. Essentially, we fill out each of our individual assemblies and what type of assembly it is. In this case, we're looking at that Riley residence, which didn't pass the prescriptive path. And the reason it did not pass is because we entered in a double stud wall, right? Project was drawn as, where is the slide? It's not there. Sorry guys, I thought there was a slide that showed the detail. But essentially we've entered that in, and notice there's a blue note that says only interior load bearing types allowed. Of course, this was an exterior load bearing, so it didn't qualify. But regardless, we enter in the different wall types that we're looking at here. So we have a bunch of user-defined entries, double stud entries, ICFs, SIPs, etc. Right? And again, this will all tell us if we're meeting the thermal resistance values that are required and if we're meeting the moisture control requirements. Moving on to point 6, excuse me, the moisture risk limitation. Again, this is going to happen as a result of our windows and doors that we're inputting into this requirement, right? So if we see this green yes, we're looking good. Essentially, all that happened here is up above, we've entered in the U value of the window. And again, the calculator, the checklist actually calculates if you are satisfying the criteria or not. And I know we're kind of running out of time, so I'm just making sure we're hitting all of the requirements here as far as the principles.
John, we can go a little bit over, so I'd rather have you go through it in detail.
Okay.
If people have to go off, that's fine. So feel free to take extra time and go through every slide that you like.
Okay. No, I think we're actually in a good pace, but I do want to make some time for Q&A too. So we only have really one left, which is kind of a group between all the mechanical systems, right? So we have mechanical ventilation and mechanical systems, principles 7 and 8. As you can see, again, there are specific climate requirements. So we have things like sensible heat recovery efficiency, total energy recovery efficiency, etc. Right? So depending on the type of project and where the project is located, it'll tell us exactly where we want to hit. It's really that simple when it comes to mechanical systems. Last thing on mechanical systems is we have some specific things that are a bit new when it comes to electrical consumption. And that is that we are now requiring EV readiness. So essentially we require an EV charging station. I'm sorry, we don't require an EV charging station, but we require the ability for a future EV charging station, right? So that can be found in section 9 here in the prescriptive checklist. The specifics of that look like a panel box with an empty breaker, right? That's labeled and says for future EV charging station, ideally. The empty conduit from the panel box to your parking lot, and a parking lot. And there you go, you're EV ready. Okay. So again, that's like a very high level overview of the actual checklist. Again, we're looking at 9 sections in the checklist. You're going through with specific takeoffs of dimensions from your drawings and filling out that checklist, right, in order to show compliance. Before I open up for Q&A, I just want to share a few resources. Again, this is the type of thing that it's great to just dive in, but it's nice if you have some things that tell you exactly what to do, right? So we have at Phius.org, the certification guidebook. This has been updated for prescriptive path, kind of step-by-step instruction, right? So make sure you're getting the new Phius guidebook from Phius.org for the prescriptive path step-by-steps. That's really helpful. We also have a number of trainings, right? So if you're interested in the prescriptive path or you're interested in general training in general, check this out at Phius.org. A number of WUFI trainings as well, but we need to focus on the prescriptive path workshop. So this is a new training. We've only offered it once so far. We'll be offering it again over the summer. Does this sound like an advertisement? Kind of is. I'll be teaching the training, and I would love to see you guys there. But we'll go through this kind of general overview, but we'll also get to dive deep into the prescriptive checklist. So we have a sample project, we open it up, we open up the checklist, we answer questions, we go through it all together, we fill out a checklist together, right? So if you're really interested in it, that is a great resource where you can really get some firsthand experience with a sample project before you go and try and do it on your own. So I'm just going to put that out on there and look for the dates at Phius.org. And with that, I'll leave you guys or open it up for Q&A. Thank you so much for having me, and I'm looking forward to seeing you guys certifying projects.
Yeah, thanks so much, John. One of the questions we had is, with the new prescriptive path, does it decrease the need for a Phius rater coming alongside the project, or do you see it as being about the same?
I think it's the same for raters. I think it probably decreases the need for CPHC actually. But in a way, that's what we want to do. We want to free our CPHCs up for bigger, more complicated projects.
Okay, so we have an architect attending that said they're considering the Phius Certified Design Consultant training. Perhaps the rater, well, they're both great, right?
Yeah.
Both great. So it may diminish the consulting part, but increase the rating part.
Yeah. I mean, I think generally right now, I mean, it depends where you are in the country, but there generally are more consultants in the country, and there's a great need for raters and verifiers throughout the country. So just to put that out there, I would personally love to see more raters and verifiers in New York, where I am. But that's just enough kind of aside.
Yeah. Great question that came up is the house that you showed that failed on prescriptive volume. Wouldn't it just switch to performance then? Yeah,
exactly. So in that specific example, the house that I showed that failed because of the volume, essentially we tried it in performance path. There were some design decisions regarding site shading that kind of prevented that. And we'll just leave it at that. But yes, in general, if you're not able to certify through the prescriptive path, for instance, the double stud wall example, you can just move into the performance path instead.
That's great. Question came up, is there a mock-up house for people to practice using the prescriptive path on? Or is that something you cover in your training this summer?
That's something we do in the training.
Okay.
So we have a sample drawing set, and we kind of go through that in detail, page by page, and we discuss how to take the correct information out and actually fill out that prescriptive checklist.
Fantastic.
Yeah.
Another question.
Built yet, though.
How much does it cost for the WUFI software?
Sure. This is actually an important question.
Yeah.
So a lot of people go to the Fraunhofer website, they're the developers for WUFI, and they say they look for like WUFI Pro or WUFI Passive, which is expensive. It's a couple $1,000s. I'm sorry, but WUFI Passive, which is designed specifically for Phius certification, I think it's like $600 a year. Right. So it's pretty fair considering the other versions are like triple that for a year.
But if you join as a certified consultant or a rater, isn't there some sort of break on WUFI?
Well, when you go through your training, you get a free version of the software for a certain period of time. So that's so
you can look at, I can get the software, or why not go through the training on how to use it, and you get it for free for a period of time. So
exactly.
John, are you up to date, or do you know about the carbon? Don't you have a carbon accounting software that you're working on at Phius as well?
So Phius does not have a carbon accounting software. We do have like a very light version of a carbon calculator at phius.org in our resources. But is this about embodied carbon or operational carbon?
Well, it's my question. So I think people are starting to think about operational and embodied carbon. And I had noted that on your site, you're starting to have some tools there for people to use.
Yeah, for sure.
More to come.
Yeah, more to come. And it's certainly something regarding retrofit projects. We are developing a Revive protocol, which is essentially a specific protocol for retrofits. to make it a little bit easier and more accessible. And that embodied carbon question is really important, right? It's very tempting to use closed cell spray foam all over the place in retrofits. So like as we get into retrofits more, the more and more we're looking into embodied carbon as well.
Right. Great. One question is on the surface area, or I think the floor area to volume ratio, and that perhaps that favors larger envelopes. It does. Okay. And that's kind of a glitch in the blower door test as well, right? It kind of favors larger envelopes, does it not?
Well, it's less about the size of the envelope and more about the density, right? So if you have like a 6-story building, but there's only 2 people living in it, then you have very low density, but you have a high envelope. Typically, we're starting to always see these big buildings paired. They're always multifamily, right? So multifamily just by nature have a very dense building occupancy. So although yes, it's easier to achieve passive building certification in large building envelopes, it's not about the size of the envelope, it's actually about that density.
Got it. We have a question on what is the issue with double stud walls, but I think it wasn't actually an issue with double stud walls. It was that the support beam was transferring thermal loss to the outside. It wasn't inside of the envelope. Is that right, John?
Exactly. And I'm glad this question was asked, because I don't want to poo-poo on double stud walls.
Oh, they're great, right?
Yeah, they're totally great. This is very specific for the prescriptive path. So essentially, we have a concern with exterior load-bearing double stud walls in certain climates, because essentially, if the exterior cord is load-bearing, there's a good risk of your dew point temperature occurring in that exterior stud, which would cause the stud to fail and structural, building goes down, right?
Yeah, you get dripping at that condensation point down into that cavity. You're transferring too much thermal energy from outside to in, right? Yeah, so double stud wall is good, but you want interior load bearing in the building envelope, right?
Right, exactly. So then you're moving the structural load and the dew point temperature away from each other. And then you're totally safe. You don't need energy modeling. You don't need anything like that. But in that particular case, we would want to look at that more closely to make sure it's safe. And we're not doing energy modeling for the prescriptive path. So we just say, sorry, you can't do that.
Makes sense. So you could perhaps default to the performance path.
Exactly.
And make some amendments to that assembly and be fine. Okay.
Exactly.
So I've got a doozy for you for our final question.
Okay.
It says, can you give some insight on why Phius approved airtight wood burning stoves, since that adds atmospheric carbon? And I think I can help you. I think I can help you out here.
I mean, it's just a cultural expectation. People really want these wood burning stoves. It's related to the question about recirculation range hoods, right? Or direct vent dryers. Like, we have expectations, and we want to make buildings that people want to live in, right? So we're trying to accommodate like the general market to make our buildings look not weird, right?
Right.
That's kind of a short answer.
And having taken some carbon accounting courses myself, one would say that there's a net balance between wood embodying carbon and then releasing that carbon from wood. It's not perfect, but yeah, I think it's a nice balance for folks, because particularly up by you, and I lived in New England, it is really hard to get people away from there.
Oh yeah, a lot of wood burning here. And frankly though, a lot of the people, I've installed a lot of wood stoves in certified passive houses, and they really don't use them that much.
Well, you have to be careful on your BTU load into a passive house, don't you? I mean, you start to get too many BTUs into the envelope, right?
Yeah, you'll overheat in a second.
Yeah, makes sense. Well, John, I want to thank you on behalf of, oh, we had one more question come in. Let's check. No, I just didn't click answer. So, okay. Well, I want to thank you on behalf of EBA, and I hope that we've caused some great engagement. And if you're a HERS rater today and you want to be a Phius rater tomorrow, please reach out to John and the team at Phius. And again, the way the government programs are set up is really that it's that pathway. I love that stepwise that you showed, John. That if you're Energy Star today, we want you to be Indoor Air Plus tomorrow. If you're Indoor Air Plus, we want you to be Zero Energy Ready. If you're Zero Energy Ready, Phius is what you want to start learning about. It really steps pretty naturally up into the Phius, and they've got great programs, great education, great local groups. So John, yeah, thank you again. And thanks to everyone at Phius.
Yeah, and I put my email in the chat. If anyone wants to reach out, I'd be glad to speak with them more.
Fantastic.
All right. Thanks a lot, guys. It was really nice speaking with you all.
Great. Thanks, John.
All right. Take care.